All right. Hello everyone. Welcome to this video. In this video, I'm going to talk about quadratic equations, quadratic form, and the discriminant. Okay. Now, before we had a quadratic like this, right? So we have in the form of x squared plus bx plus c, or the general form would be ax squared plus bx and plus by c. And just like the if you want to find the value of x that satisfies this equation, how do we find a value of x when we have a quadratic equation? So x squared plus 5x plus 6 maybe equals to, let's say, 0. How do you find that? Okay, so we have to use a factorization. If you remember that we need to find a number which adds up to, so uh, p plus q must add up to negative b, actually b, and p times q must add up to our c here. Okay, now for this example, we have a quadratic equation in the form of x squared plus 5x plus 6. So we have x plus 3 and x plus 2. Why? Because 3 times 2 is equals to 6, and 3 plus 2 is equals to 5. And this is set to 0. Now, what does this mean? So either one of them can be a value of 0, because 0 times anything, it will be 0. So we set x plus 3 is equal to 0, or we have x plus 2 is equals to 0. So the solution must be x equals to minus 3, or x equals to negative 2. If we check, if we put the values inside of the quadratic equations, does it equals to 0? So if we put negative 3 is 9, plus by negative 15, and then plus by 6. So that would be 0. If we put x equals to negative 2, positive 4, minus by 10, and plus by 6. And negative 10 plus by 6, negative 4, plus by 4 will be 0. So these are the solutions. Another example will be, what if we had negative x squared minus, let's say, 7x and plus by, let's say, um, 12. How do you do this? So again, we need to have what some number plus by some number equals to our negative 7, and it multiplies to 12. So we can actually make this form to find what times what equals to 12, but it adds up to negative 7. So the possible multiplication of 12. So let's try from the lowest, which is 1 times 12 is just 12. So negative 1 times negative 12. Yeah, it's nowhere near there. What if we do 2? 2 and 6? Oh, no. If we add them, it will be 8. So it's already greater. If we minus them, it will be 4. So it's not. What if 3 and 4? 3 plus 4 will be 7, right? And 3 times 4 is 12. What if we put negative 3 and negative 4? It will be positive 12 and negative 7, because we add them, it equals to negative 7. So our solutions must be in form of x plus, don't forget, minus 3 and times by x plus minus 4 is set equals to 0. Then we have x minus 3 or x minus 4 is equals to 0. So x equals to 3 or x equals to our positive 4. All right. How about we get a coefficient of greater than 1 in our x squared? So let's say x squared plus 5x plus 3. Okay, is equal to 0. Okay, so the trick is we multiply 2 and 3. We have x squared plus 5x plus 6, if you remember from the previous videos. And then we factorize this, x plus 3 and x plus 2. Since we had the original 2, we divide both sides into, and if it becomes a decimal, or we cannot divide it, and it will become a fraction, then we put the 2 in the coefficient as a coefficient of x. So if we divide by this by 2, we cannot, so we have 2x plus 3. And this one, it will be x plus by 1 equals to 0. Then we set it both of them equals to 0. Thus we have x would be negative 3 half, or x would be negative 1. Nice. Okay. Another example would be, let's say if we had x squared minus 7x, let's say minus 10x, and then we add by um, let's say 16 or 15, right, is equals to, let's say, negative 1. So if we have in a form of this, we must put everything on the left side or at the right side. It's according to your what you are comfortable with. If we put it on the left side, 1 will be positive 1, so x squared minus 10x plus 16. And then we find the multiples of 16. That adds up to negative 10. Let's try 1 and 16. No, of course, let's try 2 and 8. Okay, so 2 plus 8 is 10, but we need negative 10. So negative 2 and negative 8. So our solution is x minus 2 and x minus 8 is equals to 0. So x must be 2 or x equals to 8. Alright, how about what if we had a question that doesn't equals to, doesn't have a like multiple, or we have like a fraction solutions in a case that we cannot factorize it. So let's say we have x squared plus 5x plus 4. We can factorize it, right? So we could use the perfect square method, where you let's use the perfect square method first. So if we have x squared plus 5x, remember that we have to add by 5 divided by 2 squared and minus by 5 over 2 squared plus 4. Then we have x plus 5 by 2 squared, and then 25 over 4 um, plus by 4 is equals to 0, and x plus 5 over 2 squared minus 25 and add by 16 over 4 equals to 0. You move everything to the right, x plus 5 by 2 squared, and then 20 minus negative 25 plus by 16, that will be what uh, like 9, right? Negative 9. So it will be positive 9 over 4, right? And now x plus 5 over 2. We take the square root of both sides. We have plus minus 9 over 4. And then we have 5 over 2 plus minus 9 over 4. Okay, that's the solution to this quadratic equation. And there's actually a formula for it, which is called, yeah, the quadratic formula. So if you want to find the values of x, it's equivalent to negative b plus or minus square root of b squared minus 4ac over 2 times by a. Okay, if we use that, let's say if we had a equation that is we could factorize it easily. Well, this solution must be negative 3 and negative 2, right? So if we use the quadratic equation, it will be negative 5. Don't forget it's negative b plus or minus square root of b squared minus 4 times a times c and divided by 2 times a. So if you use this equation, we will have negative 5 plus minus square root of 25 minus 4 times a, which is 1, and times 6 and divided by 2 times 1. Negative 5 plus minus by 25 minus by our 24 and divided by 2. This will result in negative 5 plus minus by 1 over 2. And we had here is, if we put 1 first, positive 1, we will have negative 5 over negative 4 over 2, and or negative 5 minus 1 would be negative 6 over 2. So it will be negative 2 or negative 3, which is correct. But how can we get the quadratic equation? So assume if we had in the form of ax squared plus bx plus by c is equals to 0. And if we divide a by both sides, it will become b over a and c over a, right? And moving the constant term into the other part on the other side, negative c over a, right? We will have this. To factor out this, we will use the perfect square method. So x squared plus ba and plus by b over 2a squared, and b minus by b over 2a squared, and then minus by c. We add by and minus by c over a. And this is equivalent to x plus b over 2a squared, and then it's equivalent to b squared over 4a squared minus c over a, x plus b over 2a squared, um, b squared, finding the common term, we have 4ac over 4a squared, right? Then we'll have x plus b over 2a squared equals to b squared minus 4ac over 4a squared. We take the square root of both sides. This will be equivalent to plus minus square root of b squared minus 4ac over by 2a, and we have x plus b over 2a is equivalent to, this is 4a squared, equivalent to plus minus root b squared over minus 4ac, and divide by 2a. Move this term out, we have negative b over 2a plus minus square root of b squared 4ac over by 2a. X equals to negative b plus minus square root of b squared minus 4ac over 2a. Okay, hence we got the quadratic equation, or the formula. Okay, another thing that I have to talk about is the discriminant. If we had the quadratic equation, x equals to negative b plus minus square root of b squared minus 4ac over 2 times a, the inside of this root is the discriminant. So the discriminant is equivalent to b squared minus 4ac. And if you take a look here, whenever the discriminant is greater than 0, then we would have two distinct, or two real solutions, two real different solutions. If d was equal to 0, then we had one solution. And if d was less than 0, then no real solutions. It will be complex solutions. Okay. Let's say if our equation would be 2 plus 2x squared plus 5x plus 3. If you put the discriminant, this discriminant will be 5 squared minus 4 times 2 times 3 would be 25 minus 8 plus times 3 would be 24. 1 would be greater than 0, right? So it would be two real solutions. How about 2x? 2x plus, let's say, 7x plus by 1. And the discriminant will be our 49 minus 4 times 2 times 1. Well, it of course will be greater than 0, so it will be two real solutions. Or if you had like 6x plus 6x squared plus 2x plus 1. And the discriminant would be 4 minus 4 times 6 times 1. It will be d less than 0, so no real solutions. Well, I believe that's it for this video. There's a lot of more to talk about, like what if we only had the solutions and we're trying to figure out what's the quadratic equation. And yeah, that will be, I think, in the next video. And so that's it for this video. Thank you for watching.